Okay, for this section, we want to solve using what's called the elimination method, or you might also see to it as the addition method. Some textbooks now have switched over to call it the addition method because you want to add two equations together to eliminate a variable. When I learned it, it was called elimination because you could add or subtract to eliminate a variable. You can still add or subtract, you just have to remember if you subtract to carry the negative through and not lose a negative. So that's why most books now are switching it over to addition and making you always add. So you have to, that way you don't have to worry about the negatives so much, I guess. But anyways, so what we want to do is to eliminate a variable. So like for this one, we have 3x minus 5y equals negative 4. And negative 4x plus 5y equals 2. So I still usually number these just so I can call them the first and second equation. You want to add the equations together to eliminate a variable. So in this case, this is a negative 5y and this is a 5y. So if they were not the same coefficient, you would have to multiply the whole equation by something to make them the same. But since they are, we do not have to do that. And one's positive and one's negative. So if we add a negative 5 and a positive 5, they cancel out and go to 0, which is what we want to happen. If they were both positive 5, you could subtract, which is fine. What most, I think, are doing now is multiplying by a negative 1, switching all the signs, and then adding. So you can subtract two equations, just if you do, make sure you, like if you put a minus out here, it's 3 minus negative 4, which is actually 3 plus 4, and so on. But anyways, I'll stick to doing just the addition part since that's what most people are doing now. So we're going to add these two equations together. So we've got 3x plus negative 4x is negative x. Negative 5y plus 5y goes away, which is what we wanted to happen. We wanted to eliminate a variable. And negative 4 plus 2 is negative 2, and you just bring the equals down. Then divide by negative 1, we get x equals 2. So if x is equal to 2, then you have to find y. So you substitute a 2 into your first equation for x or your second equation. It doesn't matter which one you do, and you solve for y. So if you, I think on the handwritten ones, I plugged it into the first one. So on this one, I can plug it into the second one. So using the second equation, we have negative 4 times x, which we just said is 2, plus 5y is equal to 2. So negative 4 times 2 is 8, negative 8, I mean. Add 8 to both sides, we get 5y is 10, so y is also 2. Which is what you also get if you plug it into the first equation. So like I said, it doesn't matter which one, just plug in your x value that you found into either equation to find y. So our answer is 2, 2. And you can check that if you plug a 2 into this equation. 3 times 2 is 6, minus 5 times 2 is 10. 6 minus 10 is negative 4, that one works. Negative 4 times 2 is negative 8. Plus 5 times 2 is 10, so negative 8 plus 10 is 2, so that one also works. So you can always check these. So for the next one, so for this one, we have 3x plus y is equal to negative 4, 5x minus 2y is negative 14. So for this one, you do not have a same coefficient. There's 3 and a 5 for x, there's a 1 and a negative 2 for y. So generally what you do is if one variable has a coefficient of 1, that's the one you would want to eliminate. You could eliminate x here. You've got a 3 and a 5. 3 and 5 you can make 15s if you multiply the top equation by 5, multiply the bottom equation by 3, and pick one of them to be negative so you can add instead of subtract. So that would be fine, except that makes your numbers big. So what I would do is y has a coefficient of 1, and these are already opposite signs. This is a plus, this is a minus. So all I need to do is I need to make this have a 2 in front of it, so I can say 2 plus negative 2 cancels out. So all I have to do is multiply the first equation by positive 2. And if I do that, 2 times 3, you have to make sure you do each thing. You can't just do the y, you have to do each piece. So if I do that, 2 times 3 is 6, so I get 6x plus 2y is equal to negative 8. I didn't do anything to the bottom equation, so I'm just going to write it down again. And then I have a positive 2y and a negative 2y, so I can add these two equations together. 6x plus 5x gives me 11x. 2y plus negative 2y goes away, equals negative 8 plus negative 14 is negative 22. Divide both sides by 11, x is negative 2. And again, you can find y by plugging in x is negative 2 either into the first equation or the second equation, solve. First equation is probably easier just because the y's got a coefficient of 1, so I would personally do that one. So I would say using number 1, 3 times x is negative 2 plus y is equal to negative 4. Just as a note, you could also plug it in over here where you multiplied by 2. You could also use that one. Most people go back to the original. So we'd have negative 6 plus y is negative 4. Add 6 to both sides, y is 2. So our answer here would be negative 2, 2. And again, you can check, plug in a negative 2 for x and a 2 for y, and both equations will work. So for the next one, we have x minus 11y is 17 and 2x minus 22y is 4. So again, you can pick which one you want to make to eliminate. In this case, you're actually going to eliminate both at the same time, so it doesn't matter. So we'll just go with x's. Since x has a coefficient of 1, this one's a 2. So in order to add these together and eliminate, I need them both to have 2's, and I need one to be positive and one to be negative. So this one's already positive, so what I would do is multiply the top by negative 2. So I would have negative 2x, negative 2 times negative 11 is positive 22. Y is equal to negative 2 times 17 is negative 34. And we didn't do anything to the second equation. So then when I add these together, negative 2x plus 2x goes away. So 22y plus negative 22y also goes away. I'm left with 0 on this side. Bring down my equals. Negative 34 plus 4 is negative 30. This is a false statement, so if it is a false statement, then you just say no solution. Just like on a substitution, if you get a false statement, it's no solution. And just because I've talked about subtracting, just so you know, do it up here above it. If I would have said oops, 22 minus 22y is equal to 4. If I would have said, so this is a 2 and this is a 1, I need it to be a 2. Let's say I didn't multiply by a negative. So I've got 2x minus 22y is equal to 34. So I've multiplied by a positive 2 instead of a negative 2, which is not what books do now anymore. They want you to always add. So they multiply by a negative so you could add. So like you can subtract these. You can take this equation minus this equation, but if you do that, just be careful because it's 2x minus 2x, which goes away. That's fine. Negative 22y minus negative 22y is negative 22y plus 22y, which goes away. So you have to just be careful. That's why books are getting away from doing the minus, because people here wouldn't actually cancel that. They would just say negative 22 minus 22 would be negative 44. So it's negative 22 minus negative 22, so it makes it a plus. So you just have to be careful if you subtract instead of add. And then 34 minus 4 is 30. Excuse me. You still get a false statement, and it's still no solution. So it doesn't matter what false statement you get, it's still no solution. But since I've been talking about that you can subtract, I just want to make sure if you do that, that's fine. Just make sure you pay attention to the negatives. So for this next one, you have negative 3x minus 4y is equal to 2. Negative 9x minus 12y is equal to 6. So if you notice here, negative 3, negative 9, 4, 12, 2, 6, or negative 4, negative 12, and 2, 6, the second equation is a multiple of the first equation, so it should be infinitely many solutions. You should get a true statement when you do this. So again, if you pick a variable to eliminate, you're actually going to eliminate both, but we'll just pick one to start with. None of these have a coefficient of 1, so you can't use that. So then you just pick either you want to work with x or you want to work with y. So I'll just say we're going to work with x. This is a negative 9. We can turn a 3 into 9 by multiplying by 3. And it's a negative, but we want to be able to add, so we need to switch. We need one positive, one negative. So I'm going to multiply the top one by negative 3 so that it switches the signs. Or like I said, you can subtract as long as you're careful. So negative 3 times negative 3 is a positive 9x. Negative 4 times negative 3 is positive 12y is equal to negative 3 times 2 is negative 6. I didn't do anything to the second equation. So now I've got a positive 9 and a negative 9, so I can add so that they'll cancel. So 9x plus negative 9x goes away. 12y plus negative 12y also goes away. I left with 0 over here equals negative 6 plus 6 also goes away. 0 equals 0. That is a true statement. If it is a true statement, instead of no solution, we have infinitely many solutions. This is where it is dependent. You can write in terms of x or y, which we've talked about in the previous video, so I'm not going to do it here. I'm just going to say infinitely many solutions and leave it alone. So for the last one here, so for this one, we have 2x plus 4y is 3, and 3x plus 3y is 2. So I want to pick a variable to eliminate. You don't have a coefficient of 1, so you can't use that. So we're just going to pick one. Generally, if I don't have one that has a coefficient of 1, I'll pick the one that has the smallest numbers to deal with. So this one, 2 and 3 and 4 and 3, neither one's too bad, but I would probably eliminate x just because it's a 2 and a 3. We can turn a 2 and a 3 both into 6s. If you pick the y's, 4 and 3, you can turn both of those into 12. So I would pick the x just because. So they're both positive. I need one of them to be negative. You can pick if you want if you want to do the top by a negative or the bottom by a negative. It doesn't make any difference. So if I want to turn 2 into 6, I need to multiply by 3. And if I'm going to turn a 3 into 6, I need to multiply by 2. And like I said, they're the same sign. We need them to be opposite signs so we can add. So I'm going to pick one of these to be a negative. I think on the notes I posted, I did the top one. Yeah, so I'll do the bottom one as a negative this time. It really doesn't matter. So 3 times 2x is 6x. 3 times 4y is 12y. And 3 times 3 is 9. Then here I'm going to do negative 2 times 3 is negative 6x. This is also where you could do 3 and 2 and then instead of adding subtract, but we'll just go ahead and do by the negative and add instead. Negative 2 times 3y is negative 6y, and negative 2 times 2 is negative 4. So now I'm going to add the equations together because I have 6x plus negative 6x. That's going to cancel, which is what we wanted. We wanted to get rid of the x's. I've got 12y plus negative 6y, so that is 6y is equal to 9 plus negative 4 is 9 minus 4, which is 5. So divide by 6, I get y is 5, 6. And you get the same answer if you pick the top to make it negative and the bottom positive. So it doesn't matter, just make their signs opposite so you can add. You'll get the same answer if you subtract and don't even fool with the negative over here. And then to find x, I'm going to plug in y is 5, 6 either into the first equation or the second equation. In this one, I would use the second one simply because this is a 3, and 3 and 6 reduce more than 4 and 6. So I would do, because when you do 3 times 5, 6, 3 goes into 6 2 times. So I would just do it that way. You can also use the first equation. It really doesn't matter. 3x plus 3 times y, which we said is 5/6, is equal to 2. So that gives me 3x plus 3 goes into 6 twice, so this is 5/2 is equal to 2. Subtract 5/2, 2 minus 5/2 is negative 1/2, and divide by 3, which is multiplied by a third, so negative 1/6. So this answer is not very pretty, but that's okay, because it left us with fractions, but negative 1/6, 5/6 is the answer. And again, you can check it. If you plug in a negative 1/6 for x and a 5/6 for y in both the first and the second equation, it will give you, it will work.